This session is actually brought to us by Giga Technologies, and Dr. Flowers is going to talk about the 5 things to check when sows don't get pregnant. And I'm amazed that he could get his list down to 5, just knowing Dr. Flowers usually has a lot longer list of instructions to give. I know he has a longer list than that when he gives instructions to me. But as all of you know, Dr. Flowers is world renowned for his knowledge in swine reproduction. He's a William Neal Reynolds professor at NC State. Has taught more students in swine management roles, and much of the leadership in North Carolina. Pork production has gone through his classroom, and he's well recognized for that. And we're very pleased that Billy has been able to join us today to bring this talk. So Dr. Flowers.
Thanks, Dr. C. And I'd like to thank everybody for attending, those in person and online. You know, I was talking to lots of folks I haven't seen in a while, some just a couple of years and some for longer than that. And the only thing I learned about the pandemic is I just don't like doing things online. So it's great to be back in person. And so what I want to try to do today is visit with you just a little bit about some things that I've seen probably just before the pandemic started, and maybe through the pandemic, some of these things may have been sort of amplified because of things that happened on farms and stuff like that. So what I'm going to do is talk a little bit about records, talk a little bit about technology, and talk a little bit about things you might be able to sort of circumvent. Certainly it's not going to be comprehensive, but hopefully it'll give you a few ideas which you can maybe take home and look at your own operations or whatever operations you might be working with. So the first thing I tell people is when sows aren't pregnant, the most important thing is to actually figure out when they're being identified as not pregnant. And when I came to North Carolina years ago, I won't tell you how long ago that is, but there's a couple of you in the audience that remember that. And for those of you who aren't, just to give you a little bit of background, when I came to North Carolina, there were 17 Starbucks in the country and 36 Blockbuster videos. Some people don't even know what a Blockbuster video is. But anyway, when I go to farms, it was really neat. We would go in the office and they would have these, what we call gestation flow charts. And there'd be great big scrolls of paper, and the people on the farm would write down basically the number of sows that were still pregnant each week, and then the number of sows they bred and things like that. So now it's all either on whiteboards or their electronic systems. But this is really where it's the best place to start to kind of help you figure out why they're not getting pregnant. And so this is just an example of a gestation flow chart from years ago. And so the 2 most important areas I think on this flow chart are when the animals are being not pregnant are, let me see if I can do this. I can turn around and do it. So what you basically do is you look at right here in this red box. You see all these are 3 weeks. These are what we consider the normal returns or regular returns. And then everything else after that is what we would consider sort of irregular returns. So I've kind of highlighted those. So you really don't need to pay that much of attention to where things happen here. It's just how many happen here and then how many happen for irregular returns. The reason for that is it's all based on the reproductive physiology of the animal. So a lot of people say I talk too long, so I'll put everything you need to know about reproductive troubleshooting on one slide. And so I'm going to go over it a little bit, but the things that you really want to pay attention to are this bottom line down here with the regular return. So what we know is that after a sow's bred, she needs about 4 viable embryos between days 12 and 16, and then she gets the signal that she's pregnant. And so if she doesn't have that, it's like she never was bred, she never was pregnant, and she'll recycle on a regular interval between 28 and 28 days. If there are at least 4 embryos there at day 12 to 16, then she's programmed to go to term. And if she doesn't go to term, she's going to probably come back into heat on an irregular interval. Okay, and so that's kind of why that the number of sows recycling back at 3 to 4 weeks after bred versus everything else is really important, because it helps you dictate whether the things that happen early or later in the process in terms of reproductive physiology of the sow. So just to reiterate what I said, again, 12 to 16 days is a magic period of time for sows. That's when she knows she's pregnant. She needs at least 4 embryos. And if she does, have 4 embryos and she either goes to term, or if she doesn't stay pregnant, she's going to cycle back sometime after 21 to 28 days is what we consider the normal return interval. And so what you typically see on a gestation flow chart is things that are related to a management device or management thing, they sort of populate along a column. And so by that I mean, if we were looking at this as a situation and we're looking at the regular returns, then right here, this large number has to be something that happens within these first 3 weeks. So all these sows go through 3 weeks at a different time chronologically, but they're all falling out about the same time in terms of their management schedule. So this is what I mean by if things happen in a column, it's a management related thing. So obviously, the next question you want to figure out is if you have a lot of recycles and they're regular recycles, the logical thing to do after that is it both wean sows and gilts, or is it one versus the other? And we'll take each one of those individually. And so the reason this is important is if you think about it, this is my kind of diagram of the life cycle of a sow and the life cycle of a gilt. And the one common aspect that both sows and gilts go through on most commercial sow farms is that they're bred and they start their first sort of couple of weeks of gestation, they're treated almost exactly the same way. And so I've designated that by here. Before, the gilts actually go through a developmental period in the multiplication phase, and then the sows usually are cycling back through a previous lactation and rebreeding interval as well. So those things are different. But if you have a problem where both your sows and gilts within your groups have a low farrowing rate, then it's probably something in common that you're doing, and that's usually related to semen management, breeding, estrus detection, and probably the first 2 weeks of pregnancy, because that would dictate things that the sow wouldn't conceive and then have a normal 21-day return after she's bred. I put this picture up here, and I think probably Mark Daughtry maybe and I are the only ones that remember when we used to do this. We used to breed sows naturally to remind us, and then there's been a lot of research that's gone on over the years about semen extenders and the quality, but Mother Nature designed sperm to go from the boar to the sow with no intervention. So that should take about like 15 minutes at the most. And so what we do with AI is that we sort of circumvent that process. We collect the semen, we extend it, we keep it for long periods of time. We've made lots of progress with that, but you still have to remember, and one thing I always tell people, as soon as that semen is collected, it starts to die. And then what we try to do with our artificial insemination process is to mitigate or sort of decrease that decrease in sperm or semen quality. And the other thing that's kind of interesting, I'm going to show you a little bit of data from a basic side, is that some of the things we typically use to estimate semen quality, motility, they give us an aspect of quality of part of the sperm, but they don't tell the whole story. There are other things the sperm has to do to fertilize eggs, and some of those things actually decrease at a faster rate than motility over time. And so these are data that we took almost 30 years ago. And it was a graduate student of mine, Gene Popwell, that did this study. But what we wanted to do, this is when semen extenders were first being developed, and we had BTS, which was a 3-day extender, and then people were developing the 5 and the 7-day extenders. And we actually went and looked at the motility of the sperm and how it was stored over time. And then we also looked at some functional tests and how it's related to its ability to fertilize an egg. And so what you'll see both with the 3-day extender and then also the 7-day extender is that it does decrease slightly. That's the black line in terms of motility. And then what we have is something called, the blue line is the acrosin activity. The acrosin is the enzyme in the sperm head that actually is more sensitive to environmental changes in the sperm's motion. And then also we have in the red line over here, the ability of the sperm to penetrate the ovum. And so this was done in vitro. So we sort of took sperm at each time and actually put it in a dish and see how it looked, as well as other things. And what you'll see is in both of these is that there's a separation between what I call these functional types of things and then the motility. So that means up to a point for all extenders, these things are in parallel, but then the quality actually for some of these other things that helps the sperm fertilize the eggs get worse. And so picture's worth 1,000 words. This is actually how we do it. So this is an Ackerson test. We put sperm on a slide, and we can actually measure this little digestion halo here, and that gives us an idea about how much Ackerson it had. And then what you'll see is that you have some sperm that just don't have any. And then this is what the sperm binding test looks like. We stain the sperm heads with a yellow dye so we can see. And actually, all these sperms are motile, but you only see a few of them actually bind the egg. So we think anyway in vitro that in the live animal, if the sperm doesn't bind the egg, it's not going to get the sow pregnant. So there are some differences that way. So the take-home message is that semen starts to die as soon as it's extended. And as longer you keep it out, more of it dies. And its quality gets worse, even though motility may not change that much over time. So how do you put this in practice? And so all I've done here is just sort of diagram what might be a typical return interval for a commercial sow farm. So if you wean on a Thursday, maybe you have a few sows in heat on Monday, then more on Tuesday, and you're going to breed the ones on Tuesday a second time, so you can see your total matings and how that's distributed between first and second matings. And then when you add on top of, let me see if I can get rid of this right here. That's better. So when you add your semen age, and depending on how often you get sperm delivered to your farm, you'll have different ages of insemination dose, or what I consider different ages of sperm. And so if you're on a 3-day schedule, you get sperm Monday, you get insemination doses delivered Monday, Wednesday, and Friday. Then you can sort of see that on Monday, you get a new dose on Monday, that's the youngest. And then Friday for the previous week might be the second youngest, and then Wednesday would be the oldest. And then when you get your new delivery on Wednesday, you shift that kind of schedule. Okay. And so what I've noticed when I've been on farms just before the pandemic, and now that I've started visiting farms after the pandemic, sometimes there's a strategy to how people use insemination doses, and sometimes they just go to their semen storage unit and get what's there and start breeding sows. And I want to tell you that depending on what type of insemination program you use, it might make a difference. And so what we did, and we started this before the pandemic and we finished it up afterwards, but we went on 2 different farms, one that used conventional AI and then one that used PCAI. And what we really had them do was 2 different strategies. And what I called is first in, first out, and then last in, first out. So the first in, first out would be is you would take the oldest semen and use that to breed sows first. And then you would work your way back to the youngest semen that was delivered. So if it's, oops, let me back up. Do it this way. Got it. You see why I like teaching in person? So if you we take a look at this slide, the first in, first out would be you would use your Wednesday first because that's the oldest, and then you back up this way. Your last in, first out, you would use your youngest and breed that first, and then you go that way. So that would be sort of the difference in terms of those treatments. So with a conventional system, about 2.5 billion viable sperm, that's about 3 billion at about 80% motility, which is pretty standard. You can see there really isn't much difference, not much difference in conception or fairing rate. There was a slight improvement in number born alive by using the younger sperm, which makes sense. You have younger sperm, it's in the sow a little bit maybe. You fertilize a few more eggs that might be there, you get a little bit more of a litter size. What was really interesting is we'll go to the PCAI farms, which I'm guessing most everybody's doing in the industry now. There tends to be a little bit bigger spread. And this would be with 1.7 billion viable sperm, so that's about 2 billion doses, again, about 80% motility, which is fairly standard for most PCAI doses. What you see is you start to see a small separation in fairing rate, conception rate, and litter size. And with using the last in, first out, because you're using younger semen to breed sows first. And this makes sense to me because what we've really done with PCAI is we've moved closer to what I consider the biological limit of sperm, the minimum number of sperm we need to get sows pregnant. So when we're doing conventional AI, we have a lot more sperm because we lose a lot in the cervix. When we can bypass that with a PCAI, we actually can reduce it down. That's why I can use fewer sperm, but you're getting closer to the limit. You have less margin of error. And so one would expect with a little bit slighter, lower quality sperm and older sperm, you would actually breed maybe a few sows closest to ovulation with older sperm with this first in, first out method versus the last in, first out. So that's something to check that you might be able to go and check and look every day on your farm is how is the semen being managed and how is it being distributed in the farms. It's really pretty simple. This is our semen storage unit. We have it our swine educational unit, and we have 3 shelves, and we just move it down from one day to the next. So the youngest semen goes on the top, and then we move it down, and so folks know which one actually they need to go, which is the youngest, which is the oldest, without actually having to look at a batch or anything like that. So it's a real easy way to manage that way. So then let's say that we have this situation where we have a low farrowing rate, the sows aren't getting pregnant, and it's just the sows, and it's not the gilts. Okay. So that implies that it has to be something unique to the sows. And this is where we focus in on what the sow been through previously before she was bred. And so I always tell people if you're breeding and your gilt farrowing rate or conception rate is fine, then everything's probably okay with semen management, estrus detection, insemination strategy, et cetera, because they're doing good. And they're a lot harder to get pregnant than sows in terms of breeding. And so if you're having a problem with your sows and their regular returns, then it has to be something that she was exposed to, the gilt wasn't, and that's usually how they were managed during lactation or the immediate rebreeding period. And so this is something too that I've noticed over the years as systems have moved to batch breeding system and batch farrowing. There's a little bit more movement of pigs from sow to sow in terms of cross fostering because you have to stay on a pretty tight schedule. So if you're in a weekly schedule, you have a sow that farrows late, you can actually let her lactate a little bit longer and farrow with the next group. If you're in a batch system, you're kind of under pressure to get it moved out. And so the physiological consequences of that is lactation is a good thing for lots of reasons. One of the main things we all know is it provides nourishment for the baby pigs, but what it does for the sows, it allows her to recover and the hormones in her brain to build up to get her ready to rebreed after we wean the litter. And so I've tried to illustrate this with the diagram. If you can think of this pigling, suckling intensity, the consistency of piglet nursing. And if this is nice and consistent throughout all of lactation, then we get this nice buildup of gonadotropins. So when we wean, and 4 or 5 days later, we get this nice spike. She ovulates, a lot of eggs, and things go well. So what we tend to see on farms, and the only way you really know this was happening is if you go back and look at the sow cards. So this is a sow card from a commercial farm we were on, and it's a really nice sow card. It has previous information. They write in how many were born, and then they write in how many were fostered and when the deaths occur. And so what we spent a fair amount of time doing, and we're still working on this because we started before the pandemic and we're starting to gear it back up, is that when do piglets die, and then what effect does it have on that sort of suckling intensity? And so you can see in this situation right here, I've shown it right here, 10 were born, they fostered 4 on, and then within this sort of day 3 to day 9, she lost 4. And they're all deaths. Could be lots of different things. So what implications does that have for the sow being able to rebreed in an efficient manner? And so the way I describe it is kind of like a leaky faucet or a leaky pipe, if you want to use it in that term. And so the idea is that if these pigs die, every time the pigs die, that's a reduction in suckling intensity. If those happen within a short period of time, then chances are the sow can interpret that as maybe she's partially weaned or things like that. And that can all come from weak pigs, fostered or deaths, and that can all come at different times during that 2 to 15 day period. But the end result probably is, and this has been pretty well documented, you don't get this full recovery, and so you don't, some of the gonadotropins leak out. So when you do wean the sow at a regular time, you don't have the same level of hormone to actually stimulate ovulation and things like that. And there's an actually way you can test for that. So I'm going to go through that a little bit, or look at it on your own farm. So we all use ultrasound to scan for pregnancy, and I've shown that here in the blue. You can also, by slightly adjusting your probe and aiming a little bit higher and going a little bit higher up in the real frank, you can actually scan for the ovary. And so this picture was donated by Dr. Rob Knox. He's a colleague of mine from the University of Illinois. He's probably I would call him the foremost expert on ultrasound in sows in terms of ovarian function. He's really done a lot of work in that area. But anyway, so this kind of gives you a little bit of a diagram, because I'm going to show you some scans in a minute. So here you have the uterus, here's the bladder. It actually is in the center, and then the ovary is right here, but it's sort of back, sort of along the side. It's not in the center of the animal, there's one on each side. So these next couple of scans I'm going to show you, it's going to show you that this is a normal ovary, and this is at weaning, and then this is what the ovary would look like if we were looking at it at a slaughter plant or something like that. So here's the bottom of the probe. The red's going to show where the ovary are. This shows you actually an ovary with small follicles. And I realize it's a lot looking at ink blots. That's what people tell me, or most students tell me. But once you do a lot of scans, and you can actually pick it out pretty easily. And if you follow sows over time, it becomes quite a bit easier as well. So this is what small follicles look like on the ovary. This is normal for a weaned sow. So then this would be about day 4, hopefully, when the sow's in estrus. You've got these nice preovulatory follicles. You can see right here about the same area. You see these nice sort of circles right here. So that's progressing normally. And then hopefully at day 7, she's already ovulated, been in heat. You have these nice Corpora Lutea. Lots of, that means she's released lots of eggs. Hopefully all of them are fertilized. There's lots of progesterone, but you can see right here, these dark little circles here, they show up as like a dark little white circle, and that's the way ultrasound works. So that would be a normal scan in terms of from weaning through day 4 to day 7. And so if you're kind of interested to see what's really going on, and if this phenomenon is happening on your farm, all you really need is to scan sows at about day 6 or 7 post-weaning. And you start seeing things like this when it's abnormal. So this would be an abnormal ovary. This would be a low ovulation rate, and also an unovulated follicle. So you see this dark circle right here. This is probably analogous to this follicle that didn't ovulate. And you can see there, you see a few CLs here, but really most of it's just kind of tissue that wasn't there. So this is something that could actually happen in one of these sows that had this sort of reduced or inconsistent nursing activity during lactation. Then here we have another one. This is the extreme. This is a cystic ovary or cystic follicles. These are unovulated follicles. These girls would come into heat. You would think they have a nice strong heat because they've lost the estrogen, you breed them. And they're the ones that go out of heat, and they maybe be in heat a couple of days later. You breed them again, and then they go out of heat. But they never conceive because they never ovulate, because the follicles are cystic. And so this is what they look like. See these large sort of circles here. Okay. So what I tell people is I don't know how much this occurs, and we're just starting to collect these data, but we did go back on a couple of farms and look at the sow cards and kind of sort of categorize what we considered a consistent sort of nursing behavior. And this is in a farm that probably averaged about 13.5 pigs born alive. And so what this means is that in a consistent one, they lost 1. 0.3, which is about 10% of the pigs. That would be a really good pre-weaning survival. And then the ones that were reduced are ones that lost more. And so if they averaged 13.5, they were more like that diagram I showed you previously about losing 3 or 4 during. And you can see that there's a couple of things that kind of fit. So they have a shorter estrus, they weren't mating as much, and then the farrowing rates and the number born alive were low. And so there's really a couple of reasons this could happen with that inconsistent thing. So when you have these inconsistencies in establishing what we call the suckling-induced inhibition of gonadotropin during lactation, you can get a low ovulation rate because some follicles don't ovulate. I showed you pictures that said that some of these follicles just didn't ovulate. The other thing that happens is an unovulated follicle still produces estrogen. And so you get a situation where in early pregnancy, you don't want much estrogen around, you just want progesterone, and that's what the Corpora Lutea produced. And so you have this kind of imbalance of hormones in the early gestational environment of pigs, and that could affect embryonic development. So both of these, anyway, from a basic standpoint, could affect conception and also it cause irregular return interval. So that's something that I think that I've seen more and more of as piglets being moved, early weanings, late weanings, and things like that with the batch system, because people have to stay on the schedule. They don't have the luxury of keeping a sow or piglets over for 4 weeks for the next batch. So that's something interesting that we're still pursuing, but I think we have some interesting preliminary data that might suggest that it happens. So then we'll take the opposite of that is what happens if the ferret rate in your sows are good and your gilts are bad, okay? And so if you have regular returns in that situation, it has to be something that actually happened to the gilts during their development. Because once they get to the farm, they're probably checked for estrus the same way, they're bred the same way as the sows, they're used the same batch of semen. And in those scenarios, the ferret rates or the pregnancy rates on the sows are really good. So it has to be something that happened to the gilts before. And so we've probably spent most of the last 10 years, at least my students and I, kind of looking at the early neonatal environment and what effect that has on both adult reproductive performance of sows and boars. And for all the studies we've done, and we're not the only ones, Dr. Knauer and Dr. Cassidy have done some studies, some other people have done as well. The estimates all come back the same, is that about 50% of the sow's lifetime productivity can be explained by things that it experienced from the time it was born until it was weaned on the multiplication farm. So I'll just show you a little bit of that. So this is 2 measures of lifetime productivity. Total pigs born over 6 parities, and this is percentage of sows that were actually rebred after period 6. And this just shows you some of the things that in the litter that they were born or nursed in. These little things show you, a little box here shows you the relative percentage, but if you add all these up, you come up pretty close to 50%. So that's the nursing litter of the future replacement gilt. Variation in that kind of explains almost 50% of her lifetime productivity. So to show you some more discrete data, this is actually one of the studies, they're no longer in production, but one of the first ones we did with Goldsboro and their multiplication system, where we actually went into a multiplication farm, we measured birth weights and weaning weights, and then we tracked the sows through 6 periods. And you can see that there, at least, so this is relatively old data, but there is a subset of gilts that probably make it to commercial farms that had pretty low birth weights that really don't have much reproductive potential. And so in this case, it was pretty extreme. You can see that these were bred up here, and yet for this subset of gilts that were bred with a really low birth weight, only 40% of them fared that first litter. And so that's something to keep in mind. So birth weight's definitely a criteria that I think people could easily screen for, easily measure on multiplication farms. It's becoming more and more popular to do it, but there's still a lot of farms in the genetic nucleus that don't actually take birth weights on a regular basis. Same sort of type of trend for weaning weight, because that whole period is good. So if you noticed on that chart I showed you, both litter birth weight and litter weaning weights explain quite a bit of that variation. It just has to do with the development of the reproductive organs during that time. Same sort of thing though, this is from several different studies, but the trend's the same. You look at the heavier weaning weights, they tend to stay in the herd longer, although you don't see quite as big a decrease for gilts in their first period as you do for birth weights. And so what we did in the Goldsboro study, which is really kind of interesting, is that all the gilts, and whenever a sow fell out of production, so whenever a sow was culled because she came up as not pregnant or didn't rebreed on a regular schedule, we followed them to a local abattoir. We actually went down to Nahana, which is down the road, and we collected the ovaries and looked at them. And I just wanted to show you some typical ovaries we would see from gilts with low birth weights or low weaning weights versus those with normal. So a normal gilt may not get pregnant for lots of reasons, but we looked at all of them at the slaughterhouse anyway. And so this would be typical of a gilt that was a low birth weight. And you can see it's the same sort of pattern we saw with the sows. It's a very low ovulation rate. This ovary is small and underdeveloped. And as I count, they only have 3 CLs on this ovary. So if you go back to what I originally told you, if the gilt had 3 CLs on each ovary, that's 6. She would have probably been pregnant, but if she lost 2 of those, 3 of those, or whatever, or 2 or 3 weren't fertilized, there's your lack of 4 embryos at day 12, and she's going to cycle back on a regular basis. And then compared to the normal one that had 12 on one ovary, so that's 24. And so you can see the difference. This again would be the ovary from a low birth weight or low weaning weight, and this would be typical of what we see with the higher birth weights and the higher weaning weights. So that early developmental period for gilts is really, really important. And so this isn't something to do on a commercial farm, but I think one thing that in an industry basis in general is I think we could set and we can set sort of criteria on multiplication farms for which gilts should and shouldn't be potential replacement sows. And the tendency on a multiplication farm is that every gilt that's born should be a replacement sow for somebody. And that's not a reality of what happens, at least currently, with what we understand about gestational physiology and things like that. So then the other question to ask is, if you have your sows and gilts not getting pregnant, do you also tend to see or have a decrease in total born and or an increase in mummified fetuses or stillborns? And so if those two things go together, then what I usually tell people is the increase in stillborns and mummies or the decrease in total born is what I consider partial losses of pregnancy. So there was something going on in the herd that affected the normal development of fetuses, but the sow didn't lose all of them, so she went to term. And then probably if she did lose all of them, it happened later, after day 12 to 16. So what you tend to get is irregular returns and things like that. Those two things tend to happen. And in contrast to being a management-related event, it's probably something that happened to the whole herd at the same time. So I'll call these whole herd events. So regardless of whether the barn or wherever the sow was in pregnancy, it affected the sow, whether she's an early, middle, or late pregnancy. And so what I mean by whole herd events is that, and this is just another gestation flow chart, and this is a really neat thing about just records if you can actually collect them and use them. So we see here that we have this situation here where we have some normal returns, but then we have a pretty steady sort of change in these, what we call sows coming back in 3rd, 4th, 5th, 6th, 7th, 8th week of pregnancy. And all I've done is kind of show you the ratio of, we've got about 3 to 1 normal versus irregular return. So that's one of the parameters I use when I look at it. If we go back up here to the gestation flow chart, we can see, and if they're keeping accurate records, you can see when they're falling out. So here we had 8 fall here, and if you follow this diagonal down, you see actually there's 9 here, 7 here. So that's a situation where it affected the whole barn at one point in time, and it affected every sow in the barn. And so the reason you get irregular returns is some of those sows lost their entire litter. The reason you get an extended period of increased mummies and stillborns is that it only affected a partial litter. And it has to go with, we know right here that after day 16, basically, if the embryonic deaths occur, they're totally reabsorbed. There's no measure that they're ever there. And so you either have a low total born or the sow has an irregular return if she lost all of her embryos. The further you go along in this mid-period after you had calcification, if you have fetal deaths here, they're partially reabsorbed. Those are the mummies. And this is what this graph up here is. If you actually look at the mummies, you can tell when that mummy died during gestation. The small mummy, it died early in gestation. It was a late mummy that died later in gestation. And then what we think is stillborns die late, either during parturition or late in gestation, there's not enough time for the sow to reabsorb anything, so they come out looking normal and things like that. So if you have those two things together, you typically, it's a whole herd event, and it's kind of nice, I guess, we're having this meeting in May, because the number one whole herd event that causes irregular returns in North Carolina is exposure to heat stress, and also diseases. So anybody that's ever lived through a PRRS sort of outbreak knows exactly what I mean. You start seeing late abortions, and then ones that do FARA have lots of stillborns and mummies, and you can just track that back to the herd. So that's an example of PRRS affected the herd at the whole time, and it spread through very quickly. Heat stress has the same sort of effect as well. I highlighted this little box here. This is actually the apparent temperature. I call it the heat index for humans. Pretty much pigs feel the same sort of heat stress or temperature dynamics that humans do because they don't sweat. They probably feel a lot worse than we do. But this would be fairly typical for our barn and for a lot of barns in North Carolina. I think if your air temperature during the warmer part of the days is between 80 and 90, right? And then humidity is between 45 and 70. See, this is really what the pigs feel. And so all those temperatures are above the thermal neutral zone, or the upper level of the thermal neutral zone for pigs, which we consider 80 degrees. And so what I've always told people, there's advantages to living in North Carolina and raising hogs in North Carolina. The summertime isn't really one of them. We have these long periods of high humidity and high ambient temperature. Friends that visit me from other places and students that come from other places, I tell them we have two seasons. We have winter and summer. We really don't have fall and the spring. And you really need to consider that we're entering that period now that the summertime puts extra stress on sows during gestation. And so we have really good ventilation systems, but you can only do so much when you get up to 90 plus days and 80 to 90% humidity in barns, apart from air conditioning, which most people don't do. So realize that then what most people do, and I think everybody does it well on the farms that I've been on, is you rearrange how you might do things in your daily thing to make sure that you minimize the stress on the sows. Okay, but that's typically what we see on these whole herd type of things on the records. It starts maybe with a few sows coming in, lots of stillborns and mummies, and then it just kind of goes back through. And like I said, I usually attribute that to being sort of a partial loss of pregnancy rather than a whole loss. So, real simple to summarize, Dr. C was kidding me because I have lots of students in the audience. I usually lecture for about 50 minutes, but I didn't talk that long, I don't think, today. So anyway, I keep it short for the folks that really raise pigs for a living. So it's real simple. You have these 5 questions, figure out when they're coming back in heat, what the return is. It's either regular or irregular. And then if for both of these, is it both sows and gilts? Is it just sows and gilts? One or the other. And then here is that if you have a lot of mummies and stillborns, chances are it's affecting all sows at all stages of production. So it's kind of a whole herd event is what we call. And then really it's important to remember when you sort through and look at this is think about things that you do the same, processes that you treat gilts and sows the same versus those that are different. And then you can look to see if your fair rates or your pregnancy rates are different between those two groups of animals or not. So every farm has them, every farm has gilts and sows, and that's usually the thing. Some people actually try to break it down by parity. Sometimes when you try to break it down by parity, I tell people you get too smart because you tease it out so where it doesn't make sense. But if you just look at sows versus gilts in terms of sort these things out, it usually works out pretty well. Then the last thing I'll leave you with, so one of my favorite people in the world is Dr. Terry Coffey. There's lots of reasons I like Terry. Anybody know what the most important one is? So I married his research technician when I came to the States, and she's my wife. So I tell people the best thing Terry ever did for me is he gave me my wife. But anyway, I'll say that. But Terry actually says that he's been quoted a lot on a lot of different things, but this is the one I like the most. It says you can collect all the data that you like, and we're going to hear lots of stuff later on the talk, in the session that I'm really excited about all the modern technology, but you still have to remember that at the end of the day, once you collect the data, you still have to use it or it doesn't do any good. And the best use of it is if you can apply it to what you understand about whatever physiological process that you're working with, whether it be nutrition or reproduction or genetics. And so with that, I don't do this by myself. I had lots of students over the years and stuff. This is a few of them that helped along the way, and there's actually lots of them in the audience as well. I won't name them. I told somebody that when you start having grandchildren of former students, you're probably doing this too long, right? And so I've looked at the incoming freshman class, and I have the first grandchild of a former student. So I've been doing this too long, right? So anyway, but anyhow, that's it. So I'll be happy to try to answer any questions you might have. So. Yes, ma'am. It's a good question. So the question was, if we had a situation where I had a gilt with a low birth weight, but she gained really good, and she had a high weaning weight, then those animals are usually they act more like the high weaning weight pigs. So the way I describe it is that we think birth weight reflects how well the fetus developed in utero. And so most organs at birth reflect the animal's birth weight in terms of their development. So if you have a small birth weight pig, they have maybe lesser developed ovaries and uteri. You have a high birth weight pig, it is. And so, but it's also been shown, and we didn't do it, but we're very interested in it, that colostrum consumption can stimulate reproductive tract development in both males and females. And then there's a linear relationship between pre-weaning growth and organ development. So if you have a small pig that's born small but gains really, really well, then that can kind of sort of compensate for that as well. So my bias is, and this is just my bias, is I tend to look more at weaning weight because that's a further measure down the line than birth weight. There are other people that argue the other way that say birth weight's more important. But in our data set, weaning weight kind of explains more of the variation than birth weight. And that kind of graph that, I don't know if you looked at, but the graph that explained the thing, you saw those different colored bars. Different colored bars for weaning weight were a lot bigger than for birth weight. It's in our data set.
Really, I got a question. What are comment on batch farrowing versus weekly farrowing from a reproductive standpoint? I know that 50 years ago, batch farrowing and its farms continue to get bigger. It's only a weekly farrowing, and now it seems like the pendulum has gone back. I just wondered if you had some thoughts for reproductive physiology. What's the future? Are we going to continue with the batch farrowing?
So thanks, Ian. I think so the question was, you wanted me to have my comments on batch farrowing from a reproductive standpoint. And so Ben made a comment that years ago we used to batch farrow, then we went to a weekly production system, then we've gone back to a batch farrowing system, or batch production system. And so I learned a long time ago I shouldn't try to predict things what the industry is going to do, because as soon as I say something, they do something else. What I would say is the reproductive physiology of the sow is the same in terms of farrowing and things like that. I think the pressure we have with a weekly system for a batch system is that you have so many more sows that could be farrowing exactly at the same time that may need intervention or may need to check. It puts a lot more pressure on the workers in the barn. And so I know there's going to be some discussion later on about technology that might affect that. And I think that's the key, right? So on a weekly farrowing system, even if you have the same person to sow ratio, it tends, what I've seen, the workload tends to be spread out a little bit more. On a batch system, you know, on some of these farms, you could have 100 sows pairing at the same time in a batch system. You know, and so that's very, very difficult, you know, to give the attention to and things like that. So, but from a reproductive physiology standpoint, the changes are the same and things like that. I think it does put more pressure on management and efficient use of management and efficient use of skill management as well. So, although I've often said, and don't mean to step on anybody's toes, but I will since I'm the old fart, right? So I tell people when I go to meetings, I'm kind of like the great grandfather of the family reunion. So they say he's just in the corner, just give him what he wants and won't say anything stupid and he won't smell or anything like that. So that's the way I feel sometimes. Ask my department head, he'll tell you that. So anyway, but I do think farrowing is one where I don't think we're ever going to replace the ability of a skilled person in a farrowing barn to assist the sow when necessary. I don't think there's a technology out there. There might be technologies to help us direct that, but we're never going to replace a good person in a farrowing barn with technology.
We've got a question online.
Okay.
There's one thing that's not common but intriguing. Gilts with appropriate age and weight, not showing any sign of estrus. And then they follow into the slaughterhouse and observe that the uterus is underdeveloped before that age is weight. Thoughts about what could happen in those cases?
Yeah, so it's kind of interesting. So the question was that they don't think it happens normally, but they'll follow a gilt that's appropriate age and weight to a slaughterhouse, and then they do a slaughter check, and the uterus is underdeveloped. And so Skip Bartol, he's a colleague of mine at the University of Auburn. So he's the one that coined this term lactocrine hypothesis. So he can create those animals. He can create a large animal, a gilt that has a normal sort of size and weight by just not giving them colostrum or reducing the amount of colostrum that they have. So chances are that if it's a big pig but it doesn't get colostrum, there's things in colostrum that really specifically stimulate uterine tract development. And he's done lots of nice studies. He can tell you all the genes that change and stuff like that. But when they follow those animals through to maturity, they all have underdeveloped uteri and stuff like that. Or if they are bred, the uterus doesn't support the same number of piglets at the ovulation. So what you essentially have is an ovary that's normal, but a uterus that's underdeveloped. Okay. Yeah.
Yes, doctor, I know here in the presentation nothing related with a body condition after you wean your animal. I tell you because it's a common mistake in the industry that sometimes you regulate your feeders 20 pounds per sow. But the workers coming every day and clean it up. You are not sure that sows are eating 20 pounds, and you have sows these days that can hold 30, 40 pigs, and they come in with a really low body condition, and they don't come in in the next. Right.
So what the question was about body conditions for sows, and so I think there's a fair amount of data that really my interpretation of all the data out there is that you manage body condition on a herd level over the life cycle of the animal. So what gets you in trouble, and I've done this, if you try to adjust, so we try to do this, but if you look at the skinny sows and the fat sows and say, well, this one's not going to have eggs and this one does, that'll fool you. So body condition is important, but it's important to manage it on the life cycle of an animal, on a whole herd basis and stuff like that. So there's some fat sows that will do fine, and there's some skinny sows that will do fine as well. Now, whether most of the skinny sows do a lot worse than the fat sows, but I think Dr. Knauer actually had a graduate student, Miranda Bryan, that did really nice body condition work throughout all of pregnancy. And it's really, if you can get the animals sort of in a peak body condition, sort of that last 90 days with his caliper, then everything's good. So, but it is true, if you get them too skinny or too fat on either side of that, then their overall lifetime increases as well. So I think so I look at body condition as kind of it's like you can try to target individual sows, but I think if you have a lot of skinny sows, you need to affect your whole feeding program needs to change. Or if you have a lot of fat sows, your whole program needs to change, not just for those animals. So that's the way I look at body conditions. I would say that the farms I've been on, but just before the pandemic and the ones I've started after that, I haven't really seen too much of a body condition issue. There's a few sows, but for the most part, I think people are doing a pretty decent job with the ones that I've seen.
So we've established that there's a positive reproduction or positive reproductive performance for high birth weight, high weaning weight sows, gilts that are growing fast. As we get gilts to a breeding weight of about 300 pounds earlier, 26, 27, 28 weeks old, what's the trade-off between that weight and age? I don't know that.
Yeah, that's a good question, and I'm not sure I know that yet. So there's a lot of, there's a lot of speculation about when you have a high birth weight, high weaning weight sow, and they're rapidly growing. There is a point where you may want to slow them down, just before breeding and stuff like that. And to me, that makes a lot of sense. But if you look at all the data that's out there, it's kind of equivocal and stuff, and it's confounded the way the studies have done, because it's a very difficult study to do when you try to do weight gain, and so that you have animals that have the same weight and in different chronological ages versus the same chronological age in different weights. So I think the best, if you look at some of the meta-analysis that have been done, and lots of people have done them, it seems like there's this minimum growth rate, and it's been suggested it's about 1.5 pounds per day or something like that. And as long as they meet that, as long as they're kind of along that target, then you're probably okay. And the challenge you have is we have some that do a lot better than that. So the question is, what do you do? So I'm sorry, I don't have the answer to that. You're sitting beside a nutritionist right there. You can ask Dr. Bailey. Right, so. We done? Uh-oh.
Seasonal infertility, specifically growing rate. I mean, we're still seeing summer dips. I mean, your opinion, you had to guess. I mean, some of it is at least potentially not implementing what we already know. What else do we need to do with that to get our summer growing rates back closer to another?
The question was about summer infertility and seasonal dips, and so I would say that not to be it's so they say that there's two things that are certain in life: death and taxes. And in North Carolina, it's probably seasonal infertility in sows. We're just in a really hot, humid. Apart from putting sows in air conditioning or trying to do local cooling and zone cooling and stuff like that, it's still an issue. It's a challenge that we have. There is some suggestion, and I know it's on the boar side, but maybe not on the sow side. There are some suggestions that there are some genes in boars that impart thermotolerance to them in terms of sperm production. And so that the reason it's been discovered first in boars is because it's really easy to see if a boar is heat stressed. All you gotta do is collect the semen and look at it. And so there may be some genetic things to do, but from management standpoints, I think you accept it as a stress, and then you try to not add a lot of other stresses along. But when you have like 3 weeks where the high temperature outside is in the upper 90s and it's 90% even cool cells in barns, which do a good job, have a tough time keeping up with it, right? So to answer your question, Dr. Maddox, I'm not smart enough to know what it is. I've been at this a long time. So maybe you're smart enough and you can figure it out in the future, but I'm not smart enough. You're at the beginning of your career, I'm at the end of mine. So we done? Thanks so much.